Okay, sorry for that. Let's continue. Uh, so we're basically discussing the application of the different operands. And now we have seen that we can use the same concepts to calculate our profits. And I was asking, how do we get our average profit? How do we get it? Basically, we take profit divided by quantity. So to do that, say average profits is the same as profits we divide by quantity. So we use the division sign. Quantity. And so average profit, if we print this on intended indentation, the quantity thing was capital here. So we have your average profit, right? So in other words, we are using operands, and I think if we are looking at the remainder, I don't think we'll use this, and they'll give us, again, there's no remainder from what we did. Unless we go and change our quantity and see how it will interplay. But it gives you the possibility. We can perform modulus division. We can do that and that. There are so many ways we can play with what we have learned. We can add, we can subtract, we can divide, we can multiply. We can use it to calculate our profits, especially the issue of profits. Many times in a data set, they'll give you the cost of selling a product, the quantity that was sold, and then the quantity that was sold and the selling price. And you'll be able to, and you need to analyze the data and look at the probability of the organization. And you can look at the profitability of that organization vis-a-vis the products, vis-a-vis customers, vis-a-vis that and that. It's impossible if you cannot get your profits. And so this gives us a clue on how we can calculate the profits, right? Any worry? Any worry, please? They were all okay. Basically, this is just another example that I did. I can just share with you. And it gives you, in this example, financial calculations for a shopkeeper. I think it's similar to what we have done. Price per bag of rice. And then bags purchased, we bought 3 bags. Total cost was this. And so total cost, if we were able to get that. And we look at determining the remaining amount after buying oranges in the market, which is also another exercise. Initial amount was this, price per this, orange board was this, remaining money, how much you had, you went with the market and what you bought, what is left. Initial amount minus what you bought should give you that remainder. And so I'm just giving us the possibility of doing different calculations with what we have. So any question or any challenge in that scenario? No question. Okay. The next subheading, let me see if you have it down here. About data structures. So let's discuss now another type of operand known as comparison. Comparison operators. Now, the idea behind comparison operators is that you want to check if an outcome is true or false. So the answer will always be true or false for comparison operators. And so, if we follow up with the exercise we did, just continue from there, you discover that we may check if our x is greater than y. It's possible, right? We can check whether x is greater than y. So, for operands, we have greater than. For comparison operators, we have greater than, less than, greater than equal to, and then we have less than equal to. For instance, we can say x less than y. What should be the answer? X is 15, y is 13. Is x less than y? What should be the answer? Because the answer needs to be a Boolean. I didn't get you. This is our x here. Our x was 15 and y is 13. So the answer should be what? The answer is false. Remember that F is capital F. Answer is false because x is not less than y. X is greater than y, right? Which means if you say print, if you say x greater than y, the answer will be true. Fifteen is greater than x, right? It's greater than 13. Do we make that? So x is greater than y. So if you say x greater than equal to, we use this sign, y. The answer is still true, right? For x is greater than y. But if you say x less than equal to y, we expect our answer to be false because x is not less than, no, it is equal to y. If we say x equal to y, what would be the answer? The answer is false because x is not equal to y. We use double equal to sign. So whenever you want to use double equal to sign, want to say something is equal to another, we use double equal to sign. That's what we have there. Any question? Any question? If you want to say x is different from y, what should we use? Hmm? Nobody's talking. You say X different from use. So we use the exclamation mark, right? So those are operands that we use for comparison. Equal to, less than, greater than equal to, less than equal to, or different. So those are, and the output will always be a true or a false. You should see. Then this is another exercise which I did just to help us see what is happening. Here, let's assume that you are working and you're an electoral officer and you want to check if somebody is eligible to vote, right? It gives you that possibility to apply the concept. For instance, somebody comes and says, "What is your age?" So that the voting age, somebody is 20 years, and the voting age is what? 18. So you must be 18 and above. So let's say greater than. And so we say voting age is what? Greater than the person's age. So that's how you verify that. For instance, here, this is the person's age, the person is 20, and we know that we have set a minimum voting age which is 18. So can the person vote is a question, right? So if the person is to be able to vote, then the person's age must be greater than or equal to 18. And so if you run this, the answer should be true because this person is 20, right? And the minimum is this. So you want to check if prices of two products are different or the same. Price of, take the case of cocoa, is 3,000, coffee is this. And so is coffee more expensive than cocoa more expensive than coffee? To do that, we use the concept of greater than. If it is greater than, then it's more expensive. If it's less than, then it's less expensive. And if it's equal to, then we say they're the same. We can also check something like temperature. So weather, checking for weather, is the current temperature below the threshold? It's similar to what we have done. So if current temperature is this, and the threshold is 25, 30, and the threshold is 25, you can say whether the weather is cool or hot, depending on whether the figure is below or above. So that's the concept. Any question? Any question? Any question? So, a quick exercise. Assume that you are a mission officer in University of Buea. The condition for admission is that the person must pay fees. That's the condition. Before you are admitted, you must have paid your fees. So somebody comes out have paid, must have paid all the 50,000. Somebody comes out have paid 25,000 francs. Write a program to determine whether this person should be admitted or not, based on what we have learned thus far. Your admission officer, conditions to be admitted is